trigonometric functions of angles. T is any real number and AB a point on the unit circle corresponding to T. So T of AB is really T of cosine T, sine T. Therefore, sine T will be B, cosecant T 1 over B, cosine T will be A, and secant T 1 over A. Tangent T will be B over A, with A different from 0. Cotangent T will be A over B. Sine is equal to Y and cosine is equal to X. We're not concerned about dividing by 0. Therefore, we can take the cosine and sine of any angle. The domain for sine and cosine is the set of all real numbers. As we travel on the unit circle, we realize that the highest value of sine is 1 and the lowest value is -1. We say for sine, y must be between -1 and 1. The same thing happened for cosine. The highest value is 1 and the lowest value is -1. It follows that x is between -1 and 1. Tangent theta is sine theta over cosine theta. It is a fraction. The denominator cannot be 0. If cosine theta is equal to 0, therefore, looking at the unit circle, theta can be pi over 2, 3 pi over 2, 5 pi over 2. Therefore, theta must be 2k plus 1 and add integer, multiply by pi over 2. The domain of the tangent is the set of all real numbers except odd integer multiples of pi over 2. Cotangent theta is cosine theta over sine theta. Sine theta, the denominator cannot be 0. If we set it equal to 0, therefore theta is equal to 0 pi or 2 pi. Anytime you have the angle of an integer multiples of pi, the cotangent function will not exist. So we need to avoid k pi, with k being an integer. Now the range of both tangent and cotangent is the set of all real numbers. What is the period of trigonometric functions? Simply put, the period of a trigonometric function is the horizontal length of a complete cycle. For sine and cosine, the period is 2 pi. For cosecant and secant, the period is 2 pi. Tangent and cotangent have a period of pi. What does it mean? If we know the value of sine pi over 3, that value is the same as sine pi over 3 plus 2 pi. From the chart, the value of sine pi over 3 is square root of 3 over 2. If we go one revolution we add 1 revolution to pi over 3, that value stays the same. In short, sine theta is equal to sine theta plus 2 pi. And for a general solution, sine theta is equal to sine theta plus 2k pi. K being an integer. Now we know that if we add or subtract integer multiples of 2 pi, which is 360 degrees, to theta, the values of sine and cosine remain unchanged. Functions that exhibit this kind of behavior are called periodic functions.